So you've probably heard the terms data science and Python thrown around a lot these days, right? They are, without a doubt, some of the biggest buzzwords in tech and business. But what do they really mean? And how in the world do they get to be so important? Well, let's dive in and break down the hype, the history, and the real-world impact of this incredibly powerful combo.
And really, the whole thing just exploded into the mainstream because of this one single headline. Back in 2012, the Harvard Business Review dropped an article calling the role of data scientist the sexiest job of the century. I mean, wow, that phrase just completely captured everyone's imagination and kicked off this massive gold rush for people who could find hidden treasure inside mountains of data.
But here's the thing, this idea didn't just pop up overnight, not at all. As you can see here, it's been brewing for decades. The term itself first popped up way back in 1974. But for the longest time, it was kind of just this academic idea. The real game changer came in 2008, when the big tech companies, we're talking Facebook and LinkedIn, officially created the title data scientist. That moment, plus the HBR article a few years later, was basically the spark that lit the whole fuse.
Okay, so we've seen how it got so famous. But what is data science really? Let's peel back all those layers of hype and get to what it's all about.
All right, here's the textbook definition. Now, I know that sounds a little dense, but the core idea is actually pretty simple. It's all about using a whole mix of skills, a little bit of statistics, a little bit of computer science, and a lot of expert knowledge about a specific subject to find meaningful patterns hidden inside all that messy real-world data. It's really about turning chaos into clarity.
And this is where it gets really interesting. Data science isn't just one single job, you know? It's more like a whole team, an ecosystem of roles. And this Venn diagram shows it perfectly. You've got your data scientists, your engineers, your architects, and look at that middle part. Almost 40% of their skills overlap. So they all work together, but each one has a really specific job to do.
So let's break that down. Who are these key players on the team? Well, think of the data scientist as the strategist, the one who figures out what questions we should even be asking. Then you have the data architect who builds the whole foundation, making sure all the data is stored safely and we can actually get to it. And the data science engineer? They're the builders, creating the pipelines and systems that move all that data around so the analysis can actually happen. It's this cycle that turns a simple question into a real-world solution.
All right, so if data science is the what, then we got to talk about the how. And for a huge number of professionals, the answer is one single programming language: Python. Let's dig into how it became the undisputed king of the data world.
Just look at this chart. This thing tells the whole story, doesn't it? That blue line is Python. For years, it was just another language in the mix. But then, right around 2018, its popularity just went vertical. It shot past giants like Java and C++. This wasn't just a small trend. It was a massive shift in the entire programming world, and data science was the engine behind it.
And if you're not convinced, look at this. This is how that popularity plays out in the real world, in the job market. Python is mentioned in over 90% of data science job ads. 90%! That's just complete and total dominance. If you want a career in data science today, learning Python isn't really optional anymore. It's the price of admission.
But, you know, no tool is perfect, right? Nothing is. Even though Python is king, it's super important to have a clear-eyed view of what it's great at and where it kind of struggles. So let's talk about the good and the bad, the trade-offs data scientists deal with every single day.
Oh man, this slide just captures the two faces of Python perfectly. It's like the whole experience in two pictures. On the left, you've got this beautiful, clean, interactive world of Jupyter notebooks where your ideas can just flow. And on the right, you've got the infamous dependency hell, the tangled, messy backend that can make you want to pull your hair out. It's the best of times and it's the worst of times. Okay, let's start with the good stuff. Why do data scientists absolutely love Python? Well, a big reason is tools like Jupyter Notebooks, which lets you mix your live code, your charts, and your notes all in one document. It's amazing for exploring ideas. Plus, Python is like a Swiss Army knife. It has this enormous ecosystem of libraries for pretty much anything you can imagine, which means you can build things incredibly fast. You don't have to reinvent the wheel every time.
But then, you flip the coin, and you get the not-so-good stuff. For one, Python can be a lot slower than other languages when you're just crunching raw numbers. And like we saw, managing all the different pieces of a project can turn into a real tangled mess. Now, people are always building new tools to fix these problems, but the basic trade-off is still there. You often sacrifice a bit of raw performance for Python's incredible ease of use.
Okay, enough with the abstract concepts in the code. Let's get to the real payoff. What does this all look like when it actually makes a difference in the real world? Let's look at one of the greatest historical examples of all time.
I want you to look at this map. This is London back in 1854. A physician named John Snow was in the middle of a terrifying cholera outbreak, and he did something totally revolutionary. He didn't just look at a list of numbers, he went out and plotted every single death on a map, right alongside the locations of all the public water pumps.
And the second he put it all on the map, the answer just jumped off the page. It was so obvious. Look at that. The deaths weren't random at all. They were all clustered intensely around one single source, the water pump on Broad Street. This picture told a story that no table of numbers ever could.
So armed with this data, what did they do? Something incredibly simple. They went to that pump and they removed the handle. And just like that, the outbreak stopped. That's the whole point. This wasn't just an interesting analysis. This was a direct line from data to a key insight, to an action that literally saved hundreds of lives.
So from a simple hand-drawn map in the 1800s to the insane algorithms we have today, data science has given us these incredible tools to make sense of the world. We can analyze the past, we can understand the present, but it leaves us with one final, huge question to think about. Can it ever truly predict the future?